Hey, welcome to another video. So in this video, what we're going to talk about are how to transform some of the graphs we just learned about. How to transform tangent and cotangent in terms of a vertical shift, maybe a vertical stretch or compression, and then altering the period, which is a horizontal stretch or compression, depending on how we alter that period. So we're going to take a look at that. It's very, very similar to sine and cosine in how we approach this idea. So we're going to approach this with, let's discover what causes a vertical shift. Let's talk about how we would put our period on the graph. Then we'll talk about how to adjust maybe a vertical stretch with key points, where our vertical asymptotes come in for tangent and cotangent, and then where our key points are after we start manipulating them. So that's our idea. Let's get right into it. So with tangent and cotangent, the reciprocal function for tangent, there's a few things we need to really know. The first one is that with a form that's quite similar to the graphs of sine and cosine, we have some key features that I really need you to know. Number one, anything that's added after the function, so after tangent and then you get the parentheses or cotangent, that's going to be a vertical shift. So this B is a vertical shift where plus is up and minus is down, and that should make sense. We've seen that for a long time, that affects the output. So you plug in some stuff, it does a whole bunch of junk, and then you add to it or subtract from whatever the output is. It's going to move the entire graph up or down, depending on whether it's added or subtracted, respectively. And it's important. We're going to discuss that as we go through some of these examples. The second thing, and probably the most important part here, is to get the period right for tangent and cotangent. You see, tangent and cotangent both have a period of pi, not 2 pi. And we talked about why that was. We talked about because due to the signs in the first and second quadrant and the third and fourth quadrant, we have the sign interplay. We have sort of a repeat of tangent every pi. And so what's going to happen for us is that tangent and cotangent have a period of pi. And so we're not going to put t equals 2 pi over omega. We're going to put this just as pi over omega, because that's how often tangent and cotangent cycle. That's how often they repeat. That's what their period is. Now, there is something very important here to understand. While both tangent and cotangent have a period of pi, where it's located on the graph is different. It's actually a phase shift over and then a reciprocal of the function. So here's what I need you to know. With tangent, the period centers on 0. So you'll have half a period to the right and half a period to the left of 0, of the y-axis. And so it should always be symmetric if we don't have a phase shift, if we aren't shifting left or right. We should always have a period for tangent that's symmetric about that y. The period, not the function, just the period is symmetric about that. Cotangent's different. Cotangent's very similar to sine and cosine in that it starts at 0 and then goes to pi, and then from pi to 2 pi. So tangent actually takes a little bit more work to do, and we're going to see that in our very first example. So that's really important. We need to know B is this vertical shift idea. We need to know that the period is not based on 2 pi, but on pi, and we're dividing by whatever coefficient of x that is to adjust that. Tangent happens to have 0 right in the middle of that period. Cotangent starts at 0 with a vertical asymptote, or we can think of it that way. Both of them have vertical asymptotes at the end of the period, which is really nice. We're going to use that. And have an x-intercept in the center, and then have -1 and 1. For tangent, it's -1 and +1 at the first and third quarters. And for cotangent, it's +1, -1 at the first and third quarters. So we're going to use that. So here's the whole idea of what we're going to do. We're first going to identify any vertical shift that we have, if we have one. We're then going to take a look at our period based on pi and cut it, if we have to, by whatever the coefficient of x is. We're going to put that period on the graph. So either on the x-axis or on the shifted version of that, or on both, if we do have a vertical shift. After that, we're going to determine where our period is. So our period says we're going to start in the middle with tangent with a 0 and do half a period left and half a period right. That's harder to do than most of them. With cotangent, we're going to start at 0 and just go a period to the right. And then we're going to say, okay, what happens? At the center of that period, you'll have an x-intercept for both of these. With tangent, you'll locate the first quarter and the third quarter, just go -1, +1. And with cotangent, +1, -1. And that's about it. We'll use whatever our amplitude, it's not really an amplitude, whatever our A is to adjust our key points, and that'll give us a vertical stretch. So let's get right into it. Let's take a look at 3 tangent of x. So the first thing we're going to identify is, do we have any sort of a vertical shift? Vertical shifts have to happen at the end of your function. So after your function happens in the add or subtract. So we don't have one. There's nothing being added or subtracted, which means that our x-axis is where we're going to put our period. The next thing we do is we talk about that period. So our period for tangent is based on pi. That's how often it cycles. But we also know that we can adjust that period or give it a horizontal stretch or compression by dividing by whatever that number is. Now, if that's 1, then our period is just pi. So here's what I'm going to teach you. With tangent, it's very important to understand that the period of tangent is pi, but it's centered around 0 or centered around that y-axis. So if that's the center of the period, well then how can we put a period of pi? Well, we don't want to go all the way over to pi. Now think about that. Think about why that is. If we went all the way to the right pi and all the way to the left pi, then that would be 2 periods. It'd be 2 pi from the very far left to the very far right, and that's a problem. So here's how I always approach doing the period of tangent. I start at 0 if we do not have a phase shift, if we're not shifting left or right. I start at 0 and I take that, whatever this is, and I divide it by 2. That's going to give me the interval to the right, and then negative gives me the interval to the left. So I'm going to take a look at that and go, okay, pi divided by 2 is pi over 2. That's going to be our rightmost end of our period, if you will. Now, what's nice about this is wherever we have that 0, if we shift it, then where we shift it acts like a 0. That's fine. Wherever we have that, that is the center of our period for tangent, which means you have this sort of a symmetry as far as your period is concerned. So if we're pi over 2 to the right, and this is the center, pi over 2 to the left has to be the left-hand side of that particular period. We just make it negative. Now, so that we've determined we have no vertical shift, we have this period of pi. Think about it. From negative pi over 2 to positive pi over 2, you have to be thinking, yes, that is a period of pi. There's half a pi to here, half a pi to there. We all know 1/2 a pi plus another half a pi. You get that full pie. It's delicious. So that's our period for this. Now, what happens next? Use some of the key features that we understand about tangent, understanding that at the ends of your period, you're going to have a vertical asymptote. So we're going to put that up there. We're going to put vertical asymptote at the ends of our periods, right here at negative pi over 2 and right here at pi over 2. We're also going to put an x-intercept right at the center, in this case, right at the origin. So we've done that. We have our vertical asymptotes at the ends of our period. We have the x-intercept at the center of our period. That's great. But we also have some important features at the quarters of our period. And so what we're going to do is take this, which is nice that it has 0, and figure out what this is. So typically what happens is you need to go halfway between 0 and that. If it's 0, that's very convenient. If it's not 0, you might have to do a little bit of math there. But figure out, in this case, it's just pi over 4. How you can always do it is add these up and divide by 2. That will average them, or find the middle, find the mean of that. And so that's going to be pi over 4. And of course, the same thing, negative pi over 4. Symmetry is great for us on the period. So some important things are going to happen with tangent at the quarters. And this is what I always do. I always do the vertical shift. I always find my period second. I always write it out there, make sure my asymptotes are at the ends, my x-intercepts at the center. I find my quarters first. My first quarter, second quarter is the middle, and then the third quarter is right before the end of that period. This is what's going to give me my, what I call key points. So here's how key points work. Take your first quarter, and your third quarter. Remember that tangent climbs, cotangent falls. Tangent naturally climbs. So you're going to have a -1 and a +1. That's where we get our key points from. So you'll notice in the last video, I really didn't give you like the negative pi over 4 specifically. I just said, hey, at the first quarter, you're going to have -1. At the third quarter, you're going to have +1. Now, here's why we do that. Whatever our coefficient of our function is, that number right there, it's going to affect your key points. So the whole thing that we go through with tangent and later cotangent is find your vertical shift, put it on your graph. Find your period, put it on your graph. Find the ends, vertical asymptote, center, x-intercept, quarters, and create for yourself your original key points. First quarter -1, third quarter +1. And then if you have anything being multiplied right here, that is going to multiply those two key points. It's going to do a vertical stretch or compression, depending on whether that number is larger than 1 or smaller than 1. It can also reflect it if it's negative. And so we check that out. So for us, because that's 3, we're going to multiply this by 3. Not the input. You can't change that period. That would have happened here inside of some parentheses, and that's not the idea. This is affecting the output. Look at why that would happen. You plug in a number, tangent does something, and it says, hey, take the output, and multiply it by 3. Output multiplied by 3 is going to stretch that out. Had to adjust my graph a little bit, but here we go. So if we're going to put these now adjusted or stretched out key points, negative pi over 4 comma negative 3, that's here. And positive pi over 4 comma positive 3. And so this is going to be a very skinny looking graph. So this goes all the way from negative infinity to positive infinity on that y-axis, but it's going to be stretched out. So it's going to appear more horizontally narrow. And that's a decent picture of what tangent looks like in what we'd say is the first period. So negative pi over 2 to pi over 2. This has just been stretched out a little bit vertically. And I hope that makes sense to you. I hope you're seeing the idea. I really hope you're seeing the similarity with sine and cosine, that we've gone through the same steps. Now, oftentimes you'll have to give yourself another cycle. So take this and expand it. Now, how we do that? Just take and add your period, whatever you have here. Add it to the end or subtract it from the end of your period. So pi over 2 plus pi, well, pi over 2 plus 2 pi over 2, that'd be 1 pi, is 3 pi over 2. That's going to give us another end of a different period. So another period of this plus pi is pi over 2. Pi over 2 plus pi is 3 pi over 2. In the center of that is just pi. Now that should make sense. The center here is 0. 0 plus pi is pi and gives me another center of a different period. And so we can again draw another vertical asymptote. We can find our quarters. We can put an x-intercept at the center of that period. So I've gone ahead and I've done that. I've put my vertical asymptote, I've put my x-intercept at the center of that different period. I've also taken and found my quarters, 3 pi over 4 and 5 pi over 4. And how do you do that? There's a couple ways you can. Number one, you could average 1 pi and 3 pi over 2. You can do that if you want to. You could also take your first period and just add pi. So pi over 4 plus pi is 5 pi over 4. And negative pi over 4 plus pi is 3 pi over 4. I do it with fractions. I just take a listen and think about this like 1/4. So 1/4 plus 1 whole pi, that'd be 4/4. Well, that's 5/4 or 5 pi over 4. Same thing with this. And now, because we understand not just this key point idea, but what this really represents. Yeah, that says negative pi over 4, but what it really stands for is the first quarter of your period, comma, -3. Okay, so here's the first quarter of my period, comma, -3. And this stands for the third quarter of my period. So first, second, third. The third quarter of my period, comma, +3. So we just go ahead and put that again. And we get Hopefully, I drew a little bit funny, but we get the same exact look. It's just going to repeat, just like sine does, just like cosine does. It's just that here we have some vertical asymptotes that make us obey them. So we have to be the same looking graph every single cycle. And I hope that makes sense. I hope that you understand the technique of graphing that I've given you. I've built this off of the college algebra and even the intermediate algebra. I teach it all the same exact way, how you graph, because it really doesn't have to change. So that's what I would like you to do. Hopefully it makes sense on what we're talking about for the key points, like, hey, that's first quarter. I don't really care if it's negative pi over 4. It's the first quarter of whatever period it is. If we understand that tangent's period centers on 0, or where we shift that to or from, that's going to help us out a lot. It's pi for tangent, and then we adjust that and center it on 0. Cotangent's a bit different. We'll see that in a couple more examples. Right now, let's go ahead and let's look at this one. It's going to have a vertical shift to it. So now that we have y equals -2 tangent 3x plus 1, maybe you can start identifying what's going to happen here. We should be at that point. We should understand that that plus 1, that's going to be a vertical shift up 1. We should understand that that 3 is going to start cutting the period. What's that mean? That means it's going to make it horizontally compressed. That 3 takes that number and divides it. That's what's going to happen. It's going to be pi over 3. Centered at 0 means pi over 6 and negative pi over 6. We'll get to that in a second. But that's going to shorten this period. What that means is going to horizontally compress this graph. What's that -2 do? That -2 is going to reflect this and vertically stretch it. So there's 4 transformations here. Up 1, horizontally compressed, vertically stretched, and then reflected. I hope you're seeing that. Let's go ahead and let's do it now. So the first thing that we deal with pretty much any sort of our transformations is a vertical shift. Since that says plus 1, this is a vertical shift up 1. We're going to do that. The other thing that we're going to do is take a look at our period. Tangent and cotangent are the only 2 trig functions that have a period of just pi and not 2 pi. And so we're going to take a look at that and go, okay, if our period is just pi, we're going to take and divide whatever that pi is, whatever the period is, by whatever that number is, and that's 3. So what this does is it says, take your period and make it smaller. That squishes your graph. That's called a horizontal compression. So here's what this means. Our period is now pi over 3. What's pi over 3 do? Pi over 3 is the period of tangent in this particular function, but it's centered at 0. So this goes back to exactly what I was talking about here. We are about to put our period on the graph, but remember, tangent centers at 0. So what do? We said if this period centers at 0, there's going to be pi over 2, half of this to the right, and negative pi over 2, half of this to the left. Let's do the same thing. Let's say this is pi over 3. Half of it's going to be to the right of 0. Let's see, pi over 3 divided by 2 is pi over 6. How do we do that? If you want to ever divide a number by 2, you can multiply the denominator by 2 and do the same thing. So pi over 3 divided by 2 is the same thing as pi over 3 times 2. That's pi over 6. So this period is going to go from negative pi over 6 to 0 to positive pi over 6. That's going to be that interval. That's going to make sense. It's got to make sense that pi over 3 being split right down the middle, right at 0, is going to be negative. Pi over 3 being split down the middle is going to be negative pi over 6 to positive pi over 6. Let's put that. I'm going to put it in 2 places. And you can actually do it right now. You can always find distance between 2 numbers by subtracting them. So pi over 6 minus negative pi over 6. Let's see, minus and negative is adding. That's 2 pi over 6 or pi over 3. This has a period of pi over 3 just like we want. It's centered at 0 just like we said it does. Tangent has 0 at the center of that period, and that's exactly what we have. We have not shifted this left or right. This does not have a phase shift is what that's called. So that's great. You'll also notice that I put the period on my x-axis and where I shifted this. So this is going to act like our x-axis. As far as our key points are regarded, this is going to act like that. We're going to do everything from there. Even though it's not really there, it shifts the whole graph up. It's a nice graphic organizer to say this is where all of our stuff is really. So we've done that, and now we got to find the quarter of our period. So I've done find the shift up, we got it. Find the period, we have it. Center it at 0 for tangent, no problem. Half to the right, half to the left, I got that. Pi over 3 divided by 2 is pi over 6. And now we find the quarters. So the quarters of the period say Find out what this distance is and divide it by 2. You can always do that by averaging that if you want to. So pi over 6 plus 0 is pi over 6, divided by 2 is pi over 12. Now we're going to take care of the key features that tangent has. At the ends of the period, which you've already identified, I've talked about that, we're going to put a vertical asymptote. At the center of the period, we're going to put an x-intercept, but please keep in mind, that x-intercept is based on where this is shifted to. So that's why we put that horizontal dotted line, is to say, hey, this thing's acting like our x-intercept, we're going to put our x-intercept there. Yeah, I know it's not on the x-axis, but because we shifted it, that x-intercept, even though it's not one really, gets shifted with it. So now we've got our vertical asymptotes at the ends of our period. We know that tangent has an x-intercept at the center. But because we shifted it, this acts like our x-intercept. We think x-axis right here, even though I know it's not really there, but it helps us out, great graphic organizer. Now that we've done that, now that we've identified the period, we put it on this vertically shifted graph up 1 unit. We have our asymptotes at the ends. We have our x-intercept at the center. We now deal with our key points. So remember, tangent has first quarter -1, third quarter +1. All we have to do is know the quarters. We've already done that. That's exactly what that tells you. So because our first quarter of our period is -pi over 12 and our third quarter is +pi over 12, these are our, let's call them original key points. Okay, well, what happens to them? They get manipulated, they get changed because we have that -2. That -2 is a factor. Factors multiply stuff. What do they multiply? They multiply the outputs. And so if we have our first quarter and third quarter, we know that tangent normally does first quarter 1 and first quarter -1 and third quarter +1. Now we're going to stretch these and reflect it. That -2 does both of those jobs for us. So we multiply the output by that. And that gives us our new key points. I know there's a lot going on here. I'm not really taking it easy on some of these graphs. I'm making sure that we really understand all about it. And trig functions can be a bit more difficult because we're not as familiar with them. But I really hope that you're seeing this is the same exact process I've been teaching for a long time. It's deal with your vertical shift, show it. Recognize what type of a function it is, and show some key features of it, like, hey, vertical asymptotes happen at the ends of period, x-intercept in the center. Understand the key points about it. First quarter -1, third quarter +1, and understand what this does. That factor multiplies outputs. So now we have, hey, this is going to be at the first quarter. I don't care if it's -pi over 12. I care that that's the first quarter mark of my period. It's going to be first quarter +2, all right? It's based on where we shifted to, though, isn't it? Because we shifted that up. It's based on that. This is kind of like our baseline, our benchmark right here. That's where we're at. Our key points are in relation to that. So we treat this like a new axis. Even though it's not really there. We get it. We understand the idea behind it. So first quarter, comma, +2. Third quarter, comma, -2. And if we do that, we have first quarter +2, third quarter -2. So when we show these shifts up and down or left and right with a phase shift, we base our key points on that new sort of x and y axis. Yeah, it's not really there. It's just a really convenient way to deal with it. And so that's what we're going to do. So the true points are -pi over 2, comma, 3, and +pi over 2, pi over 12, sorry, comma, -1. Those are the real points. We're just using this to get a good graph, and it's very effective. So now we're going to graph it. And that behaves exactly how we thought it would. Shift it up, shortened this way, and then reflected and stretched. And that's exactly the graph that we get. If you had to do another cycle, then we're going to add whatever this period is to it. Remember, we're not adding pi right now. We're adding whatever this period is. This is the period of this particular function. It was based on pi, but we divided it by 3. So we'd take pi over 6 and we would add pi over 3. let's see, pi over 6 plus pi over 3. Pi over 6 plus pi over 3, that's like 2 pi over 6. That'd be 3 pi over 6. That's be pi over 2. And I hope that makes sense. I hope that you're seeing that and that you also understand that 0 plus whatever that is going to be pi over 3. So 0 plus pi over 3, that should give you another center of your period, and that's exactly what that does. So we draw a vertical asymptote, we'd add pi to all of these quarters, and we get exactly the same look. I'm going to show you right now, but I'm going to not go through it very slowly. I'm going to just kind of show you the graph. Honestly, the hardest part for students is usually dealing with these fractions. How I do it, I just start adding whatever that is. So negative pi over 12 plus pi over 3, that's 3 pi over 12 or pi over 4. And then 1 pi over 12 plus pi over 3, that's going to be 5 pi over 12. Use your calculator, use your fraction on your calculator, it usually works pretty well. Now, what's important about it? What's important to understand, that stands for now your first quarter and third quarter. We already know that. We know that this is first quarter 2. So first quarter from here, from where we shifted this. First quarter positive 2, third quarter negative 2 from here. That's 1, 2. And we should get just a repeat of that same graph. I hope it's making sense. I'm explaining it to you in a way that you understand. I'm really hoping that you understand that these key points come from your quarters for tangent and for cotangent. Their first quarter and your third quarter, and we manipulate them by multiplying that number for your output. Also, base it on where you shifted to. That's important. That's why we do this in a certain order. We do our vertical first, then we put our period. Then we find the center in the quarters. Those quarters give you key points. That's at least for tangent and cotangent. The final thing is to reiterate that tangent is centered around 0 unless you have a phase shift. If you do, you center around it where you shifted to, but it does center at 0. So take whatever this is, divide by 2, and go positive and negative. What we're going to do now is come back and look at cotangent, just a couple examples there, and then we're going to be done. All right, let's get after it. So we have cotangent, 3 cotangent, 1/2 x minus 2. We're going to go very quickly through these. The only differences between this and tangent is that it's going to be, it looks like a reflected graph, it's a reciprocal, but it's going to be downward rather than upward climbing, so it's going to be a completely decreasing graph. The period is still pi, but it starts at 0. It's not centered at 0. That makes it actually a little bit easier on a lot of things we're going to do. Other than that, because we have this downward, this decreasing graph, our key points are a little different. Our key points are not first quarter -1, it's first quarter +1, and third quarter -1. And so that's going to give it its decreasing look. Let's get right into it. The first thing we do with our graphs is we find out whether we have a vertical shift or not. That's exactly what that says. We have a vertical shift of down 2. After we deal with that, we talk about the period. Cotangent and tangent both have a period of pi. How we adjust that, how we stretch that or compress that is based on whatever that number is. So we take that period, we divide by whatever the coefficient of x is. In this case, we divide by 1/2. Wait a minute, dividing by 1/2 is effectively multiplying by 2. That's going to give us a period of 2 pi. What that's done is stretch this graph out horizontally. This is a horizontal stretch, not a horizontal compression. This is going to make this a little bit wider, twice as wide. And we're going to go ahead and put that on our graph. So we're going to go from 0 to 2 pi. Remember, while tangent centered at 0, cotangent does not. Tangent, we would have done this. We would have said, okay, pi to the right, pi to the left. Cotangent starts at 0 and just goes whatever that period is. Very much like sine and cosine. It's a little bit easier. So we've gone ahead and said, hey, if cotangent has a period of, in this case, 2 pi for this particular function, then that has to start at 0. So 0 plus 2 pi is 2 pi. This is the start and the end of the first period. If we had to do another cycle, which I'm not going to show you, you'd go now to 4 pi. You'd add another 2 pi. Very similar to sine and cosine. So we found the ends of our period, 0 and 2 pi. Cotangent starts at 0. The center is pi, and now we'll find the quarters. So we have now our ends of our period at 0 and 2 pi. We got the center at pi, and we have our quarters at pi over 2 and 3 pi over 2. And we're going to put the important features on there. Our vertical asymptotes, which I've shown you, happen at the end. So it's 0 and at 2 pi. If we had gone another cycle, it'd be at 4 pi. Our x-intercepts happen at the centers, just like for tangent. The only difference is that, well, cotangent is the reciprocal. Cotangent starts at 0, is not centered at 0, and we do a -1, +1, reversed for our key points. So our x-intercept is still at the center of the period. Remember, the center of the period is now at pi, and we're going to put it where we shifted this. Now that we have our first and our third quarters, that's what's going to give us our key points. So it was really important for us to realize that with our key points, tangent is -1 and 1, cotangent is 1 and -1 at the quarters, at the first quarter and the third quarter respectively. So for us, our first quarter is pi over 2. Cotangent is going to put pi over 2 comma 1. That would be the original point on a graph with this particular period with cotangent. Now we are going to manipulate that. We're going to affect that with a 3. It's going to be a multiplier for us, but that's how we start. So we have went down 1. We found our period of 2 pi. It's not centered at 0, it starts at 0. We found the center in our first and third quarters. We know that our x-intercept's at the center, but it's where we shifted this to. This acts like your x-axis. Our key points are the first quarter, but this is our first quarter. And our third quarter, this is our third quarter. And it's going to be -1 and +1 reversed from tangent. So basically first quarter +1 and third quarter -1. That's what we have here. Now, what happens is that number right there, that factor affects your outputs. We're going to allow that to happen. So there's no reflection here. Really, there's only 3 transformations. There was a down 2. There was a taking your function horizontally, stretching it, taking your period and growing it, and then vertically stretching this. So we have our key points at first quarter 1, third quarter -1. That's exactly what cotangent says for us. And we're going to stretch that by a factor of 3, literally a factor of 3. And since we've shown those key points here at our first and third quarter, if we base it on where we shifted, this acts like our x-axis. This would be first quarter comma 3. So 1, 2, 3. And third quarter comma -3. Right about there. And you can see it. You can see that this is stretched out horizontally. That's what that period is. It's twice as big as a normal period for cotangent. It's not centered at 0, it starts at 0. And now we have our key points laid out. First quarter comma +3 because we stretched it. And third quarter comma -3 because we stretched it. There's not a reflection. There's only 3 transformations, and now we're going to graph it. If you had to do another cycle, then you would take and add another period to that. So add 2 pi to it, you get 4 pi, and the center would be 3 pi, and you find your quarters very easily on that. And you get exactly the same look. Yeah, I hope it's making sense. I hope that you're really seeing the idea of basing everything on where you shifted it and just the essential nature of finding your period first. We really, really, really have to get that. Because if you have that and you understand where it starts, all of them start at 0 except for tangent, which is centered at 0. If you understand where it starts and where it stops, you can find your center and your quarters, and everything happens at those. Our key points are very valuable. We just have to manipulate them if you have a coefficient out front. So I hope it's making sense. Let's do one more. All right, if you want to try it on your own, you really should. We're going to get right into it. We're going to take a look at this, and first thing we're going to identify is what function we have and what's happening to it. So let's see, cotangent. Cotangent has a certain set of rules that we have to follow, like a period of pi, not centered at 0, but starts at 0. We're going to have vertical asymptotes at the end of the period, x-intercept at the center, first quarter positive, second quarter negative, unless we reflect it or stretch it or something. So we identify what function we have. Maybe you have a picture in your head. Then we take a look at if we have a vertical shift. This has a vertical shift of up 1. We're going to write that down, and then we're going to show it. Then we take our period, pi, and divide by whatever that coefficient is. Now, if it's a little awkward like pi over 4, it actually becomes a little easier. This is going to cancel your pi's out. So pi divided by pi over 4, how many times does pi over 4 fit into pi? 4 times. The pi's cancel. You basically get 1 divided by 1/4, which is 4. Your period here is 4. So that's a little bit larger, not a lot larger, but a little bit larger than the normal period of pi. So this is a horizontal stretch, just a little bit. Remember, pi is 3.14 and so ish. And so if this is a little bit bigger than that, so 4 is bigger than 3.14, it's a slight horizontal stretch. It's important to know that. It's not a compression, it's a horizontal stretch. It'll make the graph a little wider. So we said up 1, we got it. We took our period. Tangent and cotangent have the same period. It's pi. It's just centered differently. And we divide by that number, we get 4. We're going to put that on our graph right now. So with a period of 4, remember cotangent starts at 0. It's not centered. Cotangent's period starts at 0. 0 plus 4 is 4. The center is 2. The quarters are 1 and 3. That's kind of nice. Kind of nice when you have a pi in there. It makes it easier. Then what we're going to do is we're going to put our key features. Vertical asymptotes at the end, x-intercept in the center. Of course, the x-intercept goes where we shifted this to. This acts like your x-axis for all of our key points, for all of our x-intercepts. So vertical asymptotes, great at the start and the stop of our period. We're going to put our x-intercept at the center, but we shifted that. So that acts like your x-intercept because it acts like your x-axis. Yes, the point is not 2, 0. It's 2, 1 because you shifted up 1. That's okay. It's just to get the graph. Now that we have that, we deal with our key points. Our key points are always given by the quarters for tangent and cotangent, which is why we want to do our period first, because it's nice to fill that out. You do the ends, do the center, do your quarters, then those quarters act as your key points. So for cotangent, we have first quarter positive 1 and third quarter negative 1. That's exactly what we have here. First quarter is 1, positive 1. Third quarter is 3, negative 1. We're just going to affect it by whatever this number is. In this case, negative 1. That factor multiplies your outputs. Just your outputs though. So 1, negative 1, sure. 3, negative 1. So this has taken the first quarter, positive 1 and reflected it. So first quarter positive 1 would have been here. We reflect it, now we're down here. Remember, it's all based on where you shifted to. This acts like your x-axis. So first quarter negative 1. Third quarter positive 1. And these are the 3 transformations that we have. We had a vertical shift up 1, no problem. We have this slight horizontal stretch. It's going to make it a little wider. And we have this reflection. So it's going to end up looking a lot like tangent, but the period's not centered at 0. It starts at 0. If you had to draw another cycle, what would you do? Well, you'd take that and add it again. You'd have 8. In the middle would be 6. You'd have 5 and 7 as your quarters. You'd have the same exact key points for your first and third quarters. And you graph the same thing again and again and again. And that would repeat every 4, as a matter of fact, because that here for this particular function is your period. I hope it's making sense. I hope that you're really seeing the necessity of identifying the function and getting the key features. So all we're going to do with this stuff is identify any vertical shift. No problem. Take care of the period. For sine and cosine, secant and cosecant, the period's 2 pi. For tangent and cotangent, the period's pi. Be very careful with tangent. The period centers at 0. All the rest of them start at 0. Tangent's kind of the oddball there. So take your period and go to the right and left of 0 by half for tangent. Cotangent's easier. Just add it to 0, and then we find out the center. Then we find out the quarters. For tangent and cotangent, make sure you have the vertical asymptotes at the end, x-intercept at the center, based on where we shifted to, acting like your new x-axis. Our key points happen at the quarters. We adjust them by maybe having to multiply. But if we base it all on treating this like an x-axis here, that shifted version, we get very nice graphs for very little work. For the last time, I hope that you understand that yes, the point is not really 3, 1, it's 3, 2. Because of that shift, this just acts like your x-intercept to give you a great picture. I really hope it's making sense. I hope you enjoyed the technique, actually. I've seen it work very well for a lot of students because it tends to click and then you go, oh yeah, that makes sense. I'm just following my process. It's not magic. It's just finding out my period, my center, my quarters, and using the features of these graphs that you understand. Hope it makes sense. We're going to come back with the graphs of secant and cosecant next time. Have a great day.